Hey everybody, it's David the AI Guide, and we're going to talk about something that just happened today. How's that for current events? So today, Blue Origin flew their 13th new Shepard flight, and on that flight were several things, but one of the things was a new navigation system for landing accurately and softly on other bodies in space, specifically the moon first, and then later Mars. So why did NASA have to invent this? Well, there's no GPS for the moon, and there's no GPS for Mars. So when the Apollo rockets landed, and we talked about this on an older video, but when Apollo went to the moon, the landing areas were huge, miles big. And of course, that won't really work as well for what NASA is trying to do now. NASA now wants to land at or very close to the South Pole. And the reason why is because they believe that there's water ice there, which obviously can be used for exploration. So to be able to land accurately and softly anywhere on a foreign celestial body with no GPS, you need to invent new technology, and that's what NASA has done. So they invented something called Splice, and they did this in partnership with Blue Origin, because Blue Origin does suborbital flights which mimic parts of a flight to or from the moon. So Blue flew NASA's Splice, not all of it, but most of it, on their flight today. And again, this is to enable exact and soft landings. On today's flight was 2 sensors and a computer that are components of Splice. Now, Splice completely is 3 different sensors and the computer. So the first of the sensors is called terrain relative navigation. It was invented by a company called Draper, and it compares what it is seeing in terms of where the spacecraft is in its landing pattern to maps that are preloaded into the computer system that's part of this terrain relative nav. So this navigation sensor has built-in software with AI to compare the sensors and what it's seeing with the preloaded maps. So AI comes in there. The second sensor is called Doppler LiDAR. Now, I think you've heard of this because I've talked about it before. And Doppler LiDAR was invented by NASA, but what other application is Doppler LiDAR used for? We've talked about it a lot. Self-driving vehicles, okay? This is technology for, in this case, the spacecraft approaching the moon to see where it is, what its rate is, what its, how much it's going up and down in terms of altitude and velocity. So this is critical, along with looking at the surface and seeing where it is compared to where it's supposed to be. And all this is analyzed by a computer that has AI algorithms. The final sensor not on this flight is another type of LiDAR, and it creates a 3D picture. But all of this stuff is complicated, number one. Number two, think about a spacecraft approaching a landing on a foreign body without a human being in it, right? And you can think about the Mars Perseverance rover, which is on the way to Mars right now and is supposed to land on, I believe, February 18th of 2021. So Perseverance headed toward Mars, or even a spacecraft headed towards the moon, is far enough away that there's transit time for the radio signals from Earth to send commands. Particularly in the case of Mars, it's way too far. the landing has to be fully automated. So AI comes into play using algorithms to facilitate these landing mechanisms that are at great distance and cannot be controlled by a human. But even at the moon, you've got some seconds that are going to go by before the radio signal arrives, and a lot can happen. To give you an example of that, the first private spacecraft to attempt a moon landing occurred in 2019, and it was built by a company in Israel. And that spacecraft attempted to land on the moon, and something happened in the last few minutes, not long before touchdown, but it resulted in a total loss of the spacecraft. So it was a great attempt, but it wasn't successful because doing this stuff is hard. It's hard. It's not like landing a plane that has a definite runway and has humans at the controls, even though planes now use what's called fly-by-wire technology so that they can take off and land by themselves. A human is sitting there to intervene if something happens, but there's a very clear area for an aircraft to land. This is not the same as landing on the moon or Mars. So you've got boulders, you've got craters, you've got uneven ground, all kinds of stuff that you don't have, for example, when you're trying to land an airplane. So inventing this kind of technology like NASA's Splice is critical to helping a spacecraft land on a body other than Earth, safely. That's the most important part, right? Not landing on a boulder and crashing, not falling into a crater and getting destroyed, not landing on uneven ground and tipping over and getting destroyed. You don't want that. Why? Hundreds of millions of dollars are spent on landers. Hundreds of millions. In the case of Perseverance, it's over $1 billion. So this is big money. And a landing attempt needs to be no fail, right? So NASA is working also on this to facilitate human landings because in the relatively near future, meaning within the next, let's say 5-ish years, humans will land on the moon again. And it's not too crazy to think that in the next 10 to 15 years, the first human landing will occur on Mars. And these are challenging and potentially life-threatening. So NASA is in the process of inventing technologies right now that will later facilitate human space travel to other bodies in the solar system, including the moon and Mars, and potentially the moons of Jupiter and Saturn, which are already believed to have liquid water oceans under an ice crust. So there's a lot of stuff that can be explored in the solar system by humans, including asteroids where precious minerals can be mined. And so NASA's inventing the technology right now to enable its Artemis mission that's going to go to the moon and Mars. So that all happened today. New Shepard flew. It flew successfully. It'll take them time to evaluate the data from the flight, of course, to see how Splice worked, but most likely it worked well. And we can see, once again, the convergence of technologies here, sensors, computers, and AI, which we've talked about quite a few times. So careers, down the road a little bit, but how about space construction, moving to the moon for a while to build habitats, or going to asteroids to mine them? How about that for a career? Something to think about. Take care. Talk to you next time. Bye. Please subscribe.